Do you know you can sketch and test Azure operation and IoT code using Polyglot Notebooks? Let's see how to do that in this video. As a developer, I do most of my job inside Microsoft Visual Studio, mainly for product development or custom projects. I use it also sketching code during study session. The introduction of C# 9 of top-level statement has simplified a lot my job of sketching code without the need of writing boilerplate class code when not really needed. But I cannot avoid the classic edit, compile, run, debug cycle. So here comes .NET Polyglot Notebooks, where I can really sketch the code with fast and easy edit-run cycles. Besides that, when I need to do operation like creating Azure resources, I have the same need, sketching code and trying Azure CLI or PowerShell commands, annotating parameters, and so on, failing and correcting commands more and more times. Polyglot Notebooks can satisfy both these needs. Let's see how to do that in this video using Azure IoT as a scenario, creating the required Azure resources and writing some C# code to send a message to the cloud. Let's begin with operation in Azure, and I will use Azure CLI inside the PowerShell cells. Please note that the IoT plugin is installed already inside my Azure CLI. So the first thing I need is to connect to my Azure subscription so I can create resources, mainly the resource group and the IoT Hub instance. Before doing that, two steps are necessary. First, let's log in to Azure. This will require to switch to the browser and log in interactively to Azure AD prompt. Then I need to ensure that I'm using the correct subscription. This is typical when I have multiple subscriptions with the same login. The previous command will list all the available subscription I can select, and so I can use its name to select the specific subscription. Now that I'm logged in correctly, I can start creating the resources I need. I begin with a resource group and I assign it Awesome Polyglot Notebooks as a name. I use West Europe as a location, but I could obviously choose any location needed by the specific process or my business. A resource group is a logical resource that contains specific instance of Azure services, but it is good practice to locate the resource group in the same region the resources are contained are deployed. So, with Azure CLI, I create the resource group. Now I can create the Azure IoT Hub instance inside the resource group we had created. For convenience, I assign the IoT Hub resource the same name as a resource group, but I can obviously could assign the name that is more useful. As already told, the location will be the same as the resource group, so West Europe again. Now I can create my first device, which I name as test device, with shared secret as authentication method, and added to the IoT hub previously created. As a result, I have all the information I need to connect to the new device. What is important here are the primary keys and the secondary key that allow the device to communicate with the IoT hub instance. But using the key directly is a little bit uncomfortable from code. So a connection string is quite more easy to do. So with the following command, I can obtain it directly. All the Azure resources are created, so I can start sketching some device code. Now I begin with a fundamental NuGet package to do the job, Microsoft Azure Devices Client. So we can type the following code in a C# cell to refer to the IoT NuGet package. The first time launching the ref command is always long to download and install the package, but after the first time it becomes more fast because the package will be loaded from the local cache of NuGet from your local PC. To refer to the classes inside the package, I need to specify the namespace. Now I am able to begin coding. In sequence, first I store the connection string that I will copy from the previous output in a string variable. Now I can include some namespaces, system.io, system.text.json, and system.text to handle strings in the code and files. Now I can define the device client object that is the proxy object to connect to Azure IoT Hub. I can configure the object from a static method of device client type that I configure the object with a connection string. As I want to send some data, and as in this demo I don't have a real device to use, I can use a sample log file to read and generate the payloads I want to send. So let's begin some code to parse a CSV file that I have, the sample data.csv, and read the data using the system.io package. What I want to do is reading the entire file as a string to split the information in rows and columns. There is an either row inside this data. I know it, so I can skip the first line. This is the content of the file. I don't need specifically any information if not only the measure value, that is the sixth column, so the column number 5. So now I can compose the payload, serialize it as JSON and convert it to a byte array. This final step is unnecessary because the message objects that comes from the device client library require a payload expressed as a byte array before sending it to IoT Hub. So we can type some code to do that. Now that we have the message to send, we can send it. So we can invoke the send event async method on the client object. Now we can put all the code that we have written inside a loop on the samples array to send a continuous stream of events. For debugging purposes and looking at some feedback from the code, we can log on the screen the JSON payload at each step. We can use the display object, so we can write the payload just in the area under the cell inside in which there is the code that is looping with the update method. And as the loop can be quite fast, we can slow down with a task delay instruction. Great. So the code now is running and we receive the feedback with the payload that is sent in each step of the loop. One thing is important to know. You see from the square on the left of the cell, that is, the cell is still running, so it is not able to execute any other code in this moment. So you have to consider this way of working just for demo testing purposes, as you cannot do anything else. At any time, a running cell can be interrupted by pressing the square button, so the cell will synchronously stop. So we are reaching the end of a demo and the events are still sending. But one question, can we check the messages if they are correctly received by OT Hub? Yes, we can, with the same advice that we have just told. We can run in any cell a code that specifically can stay indefinitely waiting for events. So with some blocking code that will show something on the output as they receive it receives something from the device. So as we have already another notebook that is running and sending the events, I need another notebook where I can use some code to read the events, and we can use again the Azure CLI from the IoT plugin to monitor events. So we see inside the running cell the output that show the events are arriving. So this ends our demo. Remember to stop the cell so you can continue to type some code. Great! I hope you enjoyed this session. The topic is quite easy, as you have probably seen the same code in many other demos and videos. What is innovative here is that the entire code sketching experience is inside a Polyglot notebook. So the takeaway of this session is the fact that you can move a lot of your experimentation inside a Polyglot notebook because you can still write .NET or command line code. Obviously, in this video you have seen just some simple task, but you can extend this demo with any scenario that you want, you like, you need to investigate. Hope you enjoyed this video. You can find this code of a session in my GitHub account, and I hope to see you in another video. Ciao!